right, so I'm sorry to be late, but anyway, so for today, we're gonna try to deal with what is the deep learning is about, which is the actually machine learning. And when we say about the machine learning and deep learning, actually we just try to discuss these two separately, right? Because because these two are kind of usually sometimes considered as a kind of a very separate kind of techniques when we try to do the what is called the data science. So today we're gonna try to do the deep learning for this. So here is a kind of because a machine learning algorithm is a kind of like a single or one or two kind of a featuring kind of approaches, right? Because we only have a kind of in case of the machine learning algorithm, we actually try to define maybe one or two kind of features like attributes from the data set, and then we actually define those things, and then let the computer train those features, right? Looking at the data, and then train the model based on those one or two features. But the thing is, deep learning by itself is a kind of like a very multi-layer approaches. So that means in this case, what deep learning do is the computer actually looking at looking at our data set from the very multiple dimensions of the approaches. And also maybe I'm gonna try explain the later, but deep learning, in case of the deep learning, um, it is not the kind of a unsupervised learning experience, but the thing is, deep learning actually have a kind of a very complicated kind of features, allows us to the integrating the very complicated features into the model to training the model, and then like understand the data set. So as you know, one of the big example about the deep learning is the deep neural network, like a platform learning by mapping features, like a processor, the simple data transformation, and then a feedback signal. But the thing is that this one is also kind of a emphasis on the learning the successive layers of the meaningful representation. So that means there is a data set in here, and then when they training it, there is a bunch of the kind of a multiple training layer process, and then get the result. So that's the kind of what machine learning is about. And then it is a little bit more kind of a forward feeding kind of approaches, because it's kind of from the beginning to the end, like a linear kind of step. So it's a simple forward DSN, because DNN, because the thing is maybe in case of the like a decision trees or random forest or some of the machine learning techniques, we sometimes going back to our training phases and then retraining the model, like a little bit kind of a recursive kind of a process. But the thing is, in case of the deep learning actually have let the computer train the model from the multiple dimensions. So that means it is a more like we can actually have a more advantage about looking at the data set by setting up the many multiple dimension of the data features or characteristics in the model at the same time in the single model. So that actually allows us to train use of the data for training the model is more like a multiple kind of perspectives. So that's the kind of what deep learning should do. Okay. So
Yes, and
yeah, yeah.
yeah, I just have a comment, and it's in that paragraph,
Uh-huh.
uh, not the last sentence, but the previous one. It says, although an intimidating subject The overarching concept is very simple and has proven highly successful across a wide range of problems. That is image classification, speed recognition, autonomous driving. Okay. One of the things that I have noticed about the deep learning in terms of when is it useful to apply a deep learning or a deep neural network, a model. And usually it works really well when the data is kind of unstructured, okay? In other words, when you're talking about tabular data, like the ones that we have been, implementing in the previous algorithms, for example, the X housing, the attrition data set, etc. Usually, deep learning doesn't perform above those algorithms for tabular data sets. Usually, it gives you the same performance that it will give you, and there's a lot of reasons for that. Okay, but in terms of, we're going to see in the example, we're going to see the classification of different handwritten numbers, which is the MNIST data set, which is a classic data set for understanding how deep learning works. The more unstructured the data is, the better suited the deep learning model is able to get some information out of it. Okay, and in the era of ChatGPT, right? In the era of ChatGPT, what we are dealing is with a very complex, right? Deep neural network, a very complex model that what it does is that it takes inputs from text, okay, from documents, okay, from language, okay, and then it gives you some results depending on how what questions do you have. So that's something that is very insightful in terms of when to apply these models. And of course, these models also require a lot of data.
Yeah, right.
For data sets that have 2,000, 3,000 observations, even 10,000 observations. We're talking about million observations here. So in that case, that is an impediment, okay, for the deep learning model to try to get some formulation out of it, those layers, to get a good model. But for example, image classification, photo recognition, speech recognition, NLP, natural language processing, etc. Deep learning really is the tool to go.
Okay, so maybe I think that you just raised some of the interesting discussion. I'm gonna try to develop this paragraph a little bit further, okay? So in here, maybe in our field, because I'm a kind of urban planning field, so in case of this image classification, we actually try to do what is called computer vision kind of a technique. I think that you guys actually heard about this kind of technique before. So we actually, maybe some researches actually done with we can actually capturing the maybe 1 million or 2 million kind of Google Street Map, like a street view. And then we can actually try, when we get those kind of street view, we actually try to characterized about what is the green area, and then what's the building area, and then what is on the road kind of things based on the color. And then based on these kind of classifications, we can actually measuring about the kind of what is called the quality of the built environment kind of things, and then we can try to relate it to these kind of outcome to the other possible additional outcome, like how those quality of the built environment can be affected with maybe for example like a well-being of the people in the that area, or how those built environment gonna be affected to the our quality of life kind of indications, etc. So actually there is a MIT research about that they actually collecting the 1 or 2 million kind of views. It is not only kind of a cross-sectional view, it is actually time series kind of a view to recognize about the changes of the neighborhood based on these Google Street View, and then measuring about those how those changes are related to this kind of a social measurement. There is also kind of those kind of things, and then in case of the autonomous driving here, maybe I would say I think that I can show you maybe this data set about the uh, so this is a big, I would say, about the example of the how built environment, in case of the transportation or urban planning is actually try to recognize the kind using these kind of a deep learning network, like from this kind of, as you can see above, uh, by recognizing these kind of pedestrian behavior on the street or automobile kind of a driving patterns, we can actually try to identify a lot of interesting thought, like capturing the like a daily automobile travel kind of a ratio, and then depending on the built environment characteristic, and then based on this kind of a pedestrian flow, and then this recognizing some of the types of the vehicle, and then also this like a pedestrian, and then how those things gonna be related to the safety overall, maybe for example, like in the overall safety on the street from those kind of built environment kind of settings. So these kind of things actually kind of example, I would say, for the deep learning kind of approaches, I would say. Yeah, maybe, yeah. And then in this case, the car actually setting up a lot of a camera, and then some of the radar and lidar sensors to find out that these all of the nearby kind of environment from the car, and then we can get those kind of images up to the top like this, or maybe uh where it is, like these kind of images we can get, so like this. So all of these kind of technique actually basically about the from the kind of this kind of a neural deep learning kind of approaches, and also identification of these kind of image classification actually have a kind of example of these kind of deep learning kind of things. So I think that might be kind of give you some of the implication about the just kind of introductory kind of things of the deep learning. Okay. All right. So and then we can, as we always, we actually have the kind of packages we're gonna loading up. But the thing is, in this case, now in case of the deep learning, I think that you guys already heard about this kind of a Keras package, because this one is a very famous and then a commonly used of the packages for the Keras is for the deep learning kind of things, especially for the neural network kind of approaches. So Keras is the kind of a big packages. Maybe I think that Keras is also kind of a package using R and Python both, right? So Keras is actually kind of a big kind of packages for the deep learning kind of things, and also we also sometimes some cover here about the H2O packages to training some of the model kind of things. And also, as you can see here, actually, in case of the deep learning, compared to the machine learning kind of things, deep learning actually have a lot of computation intensive kind of process, both CPU and GPU kind of require. And also TensorFlow, it is also mentioned the TensorFlow in here. So that one is also kind of a packages in R. And then we're gonna be deal with the Keras and TensorFlow software for the deep learning kind of program, deep learning techniques.
Yes, I
Okay.
am known in
Mm-hmm.
the difference between Keras and TensorFlow. TensorFlow is more equation related, so
Mm-hmm.
you can tune your deep model a little bit in
Mm-hmm.
more detail.
Mm-hmm.
And Keras is more a general tool, so it's just it package some
Mm-hmm.
common functions that use in TensorFlow,
Mm-hmm.
and they're a little bit repetitive, so they package in Keras. So you use Keras as your
Mm-hmm.
start point, but
Mm-hmm.
TensorFlow for more details or something that you need to maybe tune. I
Mm-hmm.
know that, yeah, that those packages are a little bit new in R, and you see the book is
Mm-hmm.
2019,
Mm-hmm.
and yeah, it was originally in Python, was created by Google.
Mm-hmm.
And the other one that is really popular in Python is PyTorch.
Mm-hmm.
And also RStudio is also working in a Torch version for R. So that's the name Torch.
Mm-hmm.
They just remove the Py part and say,
Mm-hmm.
the Torch package.
Yeah, this one is
That's
actually
active
Python
development.
package. Yeah. Mm-hmm. Okay. Yeah, because I actually heard that in Python there is a kind of a good amount of the like I would say about the packages that we can use for the deep learning. And then in case of the Keras and TensorFlow software kind of R packages, it is quite new into the R kind of a packages. So right now, yeah, as you can see here, Keras is the TensorFlow function is like a in here, and then this library like a TF runs is the kind of like after installing this kind of a TensorFlow software, I think we can actually are actually importing those kind of things and then using that TensorFlow kind of functions in our kind of things. It is also same for the Keras, I guess. Is that correct? Right?
Yeah, it's like they use those
Uh,
packages together to create the
mm,
functionality.
yeah.
Yeah, but they come from Python.
Yeah, right.
They were developed first in Python, and then
Okay.
our studio
Yeah.
uh, did the wrappers, the
Mm-hmm.
corresponding connections and wrappers to
Yeah.
get Python. The same thing as PyTorch.
Yeah.
The Torch package uses PyTorch,
Yeah.
for backend.
Yeah. Because what I know about these two things is in case of the Keras and TensorFlow, actually these two are gonna be installed separately as a kind of a software, and then in R, it's just a kind of all of the most of those functions gonna be imported to the R, and then using the R Studio kind of environment, kind of things.
Right.
Yeah.
But
So
you need but for Keras to work, you need TensorFlow. Okay.
yeah,
Yeah, because
right.
Keras, what it's going to do is kind of act as a
Mm-hmm.
wrapper for TensorFlow. So
Mm-hmm.
you can do a lot of coding in TensorFlow. You can do it maybe in one or two functions in
Mm-hmm.
Keras.
Mm-hmm.
Okay, that was the those guys, Allaire and Cholet,
Mm-hmm.
French guys.
Mm-hmm.
They built the Keras package
Mm-hmm.
to make it easier to coders, okay, and data
Mm-hmm.
scientists to use TensorFlow, okay.
Mm-hmm.
Because if you use only TensorFlow, you're going to be coding a lot. Okay,
Ah,
and
okay.
you have to yeah, you have to set up the, the layers. You have to set, the way, the data is going to be ingested, etc. With Keras, you see that, in a couple of functions, you can call those TensorFlows, functions that you need, and then, it's going to be, easier to implement.
Okay, interesting. Yeah. Okay, so Keras, what I know about the deep learning kind of things about the packages is Keras and then the TensorFlow is the kind of like a very fundamental and then very basic kind of a software and then functions that we have to use, and then from those two things, there is actually have providing a lot of kind of a derivative kind of packages using the Keras and TensorFlow. Like I just previously discussed about the computer vision things. Actually, in R, in my case, there is a lot of separate, not a lot, maybe some of the few R packages that allows us to conducting these kind of a computer vision kind of a tech process by importing the Keras and TensorFlow kind of functions, and then developing some of the computer vision kind of technique functions to the R packages, like a CV kind of things, and OpenCV, I mean, is one of the R packages that allows us to the computer vision kind of a technique. And then those kind of R packages actually uses these kind of Keras and TensorFlow kind of functions, and to make the computer vision work. So anyway, so these are the kind of packages we're gonna use. And then in here, so it also says about as Ricardo said, we're gonna use the MNIST data to understand the DNN concept. So I also know that this data, because this data is a kind of a very typical example about how we can conducting the deep learning. So there is something to new to the few item, kind of like some notice kind of things, some before we conducting the learning. Like here, the first one is feed forward DNN, like a deep neural network, is all feature input to be numeric. This one is quite important. So to learn our deep model kind of approaches, we have to be coding all of our input data as a numeric data. So even we have categorical features, we have to be assign the categorical features like a numerically coded, like a one-hot coded, or maybe integrated level coded, etc., like a 0, 1, 2, 3 kind of etc. kind of things. And also due to the transformation process of the DNN things, we actually standardize our feature first. Okay, that means we have to define the features we're gonna use in the deep learning process. We have to using the same scale level to learn those kind of features, and then train the model for the in the deep learning kind of process. So we have to be standardized or kind of standardize our features first, and then also we are working on the multi-nominal responses, like I said, 0, 1, 2, 3 kind of things. We actually try to be one hard-coded kind of matrices by using the two categorical kind of functions. So that means if we have a kind of multiple responses, like 1 through the 9, so that means like a 0, 1, 2, 3, 4, 5, and then 9, and then we can actually have a one hard-coded like this. Every these kind of things as kind of regarded as a single separate column or single separate features, even if this one is actually have a multiple kind of a multi-nominal kind of responses. Everyone has a kind of a separately kind of columns or separately features, and then we can try to say kind of a one hot coded means like a 0 to 1, yes or no kind of things for the each kind of a multiple responses. So those are the kind of three things we have to keep in mind when we try to run the deep learning process. Okay, so in here, whenever we read that MNIST data set, and then we can actually try to categorize in here in the two categorical kind of functions. This is the kind of a multiple responses. The 10 means we actually try to digitize, try to identify the images, handwriting of the numbers from the 0 to 9, which is the 10 different multinomial responses. So that's the reason why we actually set up the 10 in here, right? And also like a scale is the kind of in here, we can actually dividing for the some of the standardized value for the hour scale, like a 0 to 1 kind of a scale kind of things for the multiple attribute. Because in MNIST kind of examples, we actually have three different features, right? I'm gonna try to explain later, but one is kind of like thickness, and then angle kind of things, and then the other third one is I cannot remember, but there is a third one also mentions in here. And then these are the kind of basic features that allows us to recognize for the third one is I think the completeness, like of the handwriting. So based on these three features, actually kind of a basic criteria that allows us to the training to the model through the deep learning process, and then identifying our handwriting numbers as a digit kind of numbers. So that's the kind of things. And then why we had to use the deep learning kind of things. So as you can see here, this is a kind of our MNIST test data set example. So our data set actually have a bunch of the example for these handwriting for the 0 to 9. So like there is all like in case of these 7 kind of things, there is a whole different kind of patterns or images that the way we writing about the numbers. Cause in here, this one is actually very interesting one. Cause in the Western cultures, you guys actually writing about the 7 like this, but in the Eastern cultures, we do not writing 7 like this. We mostly writing 7 like this, as it is like this. So this one and this one is very different. So these kind of identifying these kind of handwriting patterns is what we gonna do for this MNIST data set. Because when you're looking at the way we actually handwriting to the 7 is quite like a various kind of a pattern compared to the other one. Like 4 is also another example for the writing of the numbers. So usually in the Western cultures, they sometimes writing this like this, not or maybe like this. Because Eastern cultures, we usually writing this one with the angle, like a 4. But in the Western cultures, it is more like a digital shape kind of things to representing 4. So those are also kind of we need to identify used to identify the number 4 kind of things. And also number 2 is also kind of very different, because in the 2 we are also writing 2 like this, and then also sometimes you can find these kind of images like 2 when you say about the 2, or maybe sometimes we can also using 2 like this. So all of these kind of patterns we have to understand by looking at defining some set of the multiple kind of features to understand these handwriting numbers and then digitizing it, right? In case of the 0 and 1 is very simple, like it is a circle, and then it is just kind of a matter of the kind of a line kind of things, right? Sometimes we can also say about when we say about the 1 is maybe like this or like this, or maybe even like this. There's a whole different kind of a pattern too, or maybe in this, just like this. So what the MNIST data set actually do is that this kind of recognition of this pattern, how we can modeling these kind of patterns in R. So in here, deep learning actually consists of the three kind of components. So input layer is what we really say about our data set, like original input features, like our handwriting things. And then the hidden layer is a kind of like designating the characteristic or features of the features layer that allows us to the understanding this raw data set. And then this one is the kind of a main layer we have to train the model through the deep learning process. And then after the training, those things based on these hidden layer features, we can finally recognize our model in case of our digitization of the number, producing the number, prediction number, and then that's the kind of output layer, which is the integration of these kind of set of these kind of features. Okay. Any questions so far? Anything? Okay, so as you can see here, in case of the deep learning, we actually have a lot of hidden layers, because when we have many multiple kind of features to understand our input layers, so that means we actually input these kind of input layer to the hidden layer as a kind of a phase kind of process, 1, 2, 3, like this. Maybe in the MNIST data set, maybe first one we have to understand maybe the angle of those writing, and then the next one is maybe thickness of the line gonna be another hidden layer, and then the third one is how completeness of the dead handwriting is, and then combine all of these kind of training results together, that actually allows us to recognizing the sum of the features, and then those actually gets the final result of what the number will be based on the dead handwriting. So that's what I understand about the data set. So due to the kind of a computer technology advancement, right now we actually try to set up the multiple hidden layers to understand the very unstructured or some of the image data set. As I can mention in the example that I mentioned in the previously, like a computer vision one, like a Google Street View analysis, at that time, I actually tried to categorizing to the road and building and the sky, right? Like this. And then these are the kind of like a buildings and road and sky is also maybe the example for the hidden layers. And then in that cases, we actually train these Google Street View and then recognize those images and then categorize them into these three components as a hidden layers. And then we can actually calculating the proportion of each components to measuring about the quality of the built environment. That's the way urban planning part actually used for these kind of deep learning approaches. Okay, so it is also the same thing. So as I can say here, so what is the deep learning, especially deep neural network can do is that we can actually define these kind of features as many as possible to understand our unstructured or image data set. Okay.
Keuntae, I
Yeah.
have a comment here. Okay, if you go to the preceding diagram, you know, the one that represents the simple forward network, usually this represents a classification problem. Okay, you know, it could be also a regression problem, but let's stay for classification because that's what we're doing with the MNIST. This one also only has one one result. Okay, so this model represents kind of a binary, okay, classification where the only, you know, the only outputs is going to be or 0 or 1 usually. Okay, and it's going to give you, of course, you know, it's going to give you the probabilities, right? The one that applies to the MNIST, which is the next one. Okay, now you have a multi classification problem, right?
Yeah.
You know, you are going to classify if it's 0, if it's 1, if it's 2, until 9, right?
Yeah.
So the model, you know, with the inputs, right, with the input layer, is going to then process it to the hidden layers, right? You know, which is going to calculate the weights, okay, that each of those observations, you know, have. And eventually is going to give you 9 results.
Yeah,
okay?
right.
That's why that's why it says from Y0 to Y9. And what it's going to give you is the probability that that result could be Y0, the probability of Y1, the probability of Y2, etc. And all those probabilities are going to sum 1, of course. Okay. So, for example, if we have an observation that, you know, it looks like a 5, for example, it's going to give you all the predictions. Okay, all the results the model is going to give you, but probably 5, if it is tuned correctly, the model 5 is going to be the highest probability. Okay, and then you can say, okay, this observation corresponds, you know, the output, the output corresponds to a 5. This observation corresponds to a 3, etc. So it's going to give you all the results. What you're going to get is the probability, and the highest probability will be the final results that you're looking for.
Okay, gotcha. Okay? Yeah, okay, gotcha. Yeah, and also I actually forgot to say is in case of the computer vision example, I actually say about the building and road and sky, and then we also, these are actually what is called the 3 Y responses, and then we can actually calculating about the proportion, and then based on these kind of proportions, we actually define the set of the built environment typology, and then calculating the probability of the based on these kind of things where which one is the urban area, rural area, or suburban area, or residential, commercial. We can like classifying those things based on these possible 3 layer, hidden layer kind of a training. So yeah, that is a good catch. And then these are the kind of a basic kind of a diagram for the to understand about the deep neural network. And then the feed forward DNN is kind of like when the multiple DNA architecture exists, and then these things, and then it is, I think the feed forward kind of a DNN is what I understand is it is quite like a forwarding, means it's from the input layer to the output layers. It is kind of like a very, very linear kind of a type of the approaches, like from the input layers, we can actually assign all of these kind of item kind of features can be assigned, can be considered to understand this kind of input layer. And then those hidden layer actually train this model, and then output layer gonna be predicting the depth probability of our each responses. So this kind of automatic kind of a process is the feed forward kind of a DNN is about. I think that's what I understand for this one. And then
it's kind of unidirectional. Okay,
Yeah,
it just goes
yeah.
from the input layer to the hidden layers to the output layers, and you will see that back propagation. Okay, is going to then have some output, but that output also it could be returned back to the to the hidden layers. Okay, to make the model a little bit more precise. Okay, so that's why that this this the deep learning field has progressed so much during these years because of computing power, etc. And you have all kinds of different different frameworks. Okay, but it refers the feed forward. It refers to that unidirectional that you have the input layer, the hidden layers, and the output. Sometimes you get some feedback, okay, from the output layer to the hidden layers also, which is that back propagation. Okay.
Okay.
But that's a topic for another for another lesson.
Yeah, I also personally think that in case of the Chat GPT kind of approaches, which is a kind of a emerging technology for the AI things, that is actually kind of what it says about the recursive kind of a neural network kind of things. Because these what is called this kind of a convolutional kind of a neural network. When we say about the CNN, this is actually convolutional kind of a networks, right?
Right.
It's because it's a feed forward kind of things. Like we can actually narrow down about our recognition of the data set, right? But in terms of the recurrent kind of things, we actually start from in case of the Chat GPT, they actually start with our questions, and then what that model can do, as far as I understand, is based on the questions, that model gonna be recognize some of the multiple kind of hidden inside the multiple hidden layers. They actually disassemble about the components or items or features of the questions, and then they actually going back to their kind of a searching language kind of a searching machine, and then going back to that result, and then handing back to the answers as that questions. I think that is the kind of a ChatGPT kind of things, which means it is more like a back and forth kind of approaches, like what you say about the recursive kind of a neural network kind of process. That's kind of what I understand, because it's a kind of a start from the back, start from our question, and then back to the model, and then get the answer, and then after that it actually move forward. So that actually more like a complicated one, but the thing is that one is a kind of a little bit more different example. Because a feed forward kind of a DNN is more like a convoluted kind of things. Whenever we have these kind of input layers, we're gonna be narrowed down to this kind of a classification or recognition, and then get the one or several kind of outputs to identify what this input layer is about. But maybe ChatGPT gonna be the one example for the maybe recurrent or recursive kind of a back and forth kind of a process of the neural network kind of example, combined with the natural language processing. So, but anyway, so to build a feed for DNN, we actually 4 key components, which is one is the very raw data, like input data, and then a predefined network architecture, and then a feedback mechanism to the network to run. Like this one is more like 2 and 3 and 4 is the kind of what hidden layer actually usually do, because input data is just kind of input data, and then 3 and 4 is the kind of a basic elements about the hidden layers should be included, and then combine all of these together, we actually get the output layers to understand what's the final response and then the probabilities. Okay.
Keuntae, we already reached 8 o'clock.
Okay. So, yeah, because I just try to explain the very, very slowly, and then maybe I think that we can stop here, okay, for now. And then maybe 13.4 and then the rest of the chapter, I'm gonna try to actually rest of the chapter is more like related to the how we can conducting the deep learning thing techniques in R, kind of more like a coding kind of process. So maybe next week I'm gonna cover rest of the things, and then hopefully we can done with chapter 13 by next week.
Okay. So
Okay.
I'm going to stop now, right?
Yeah.